Welcome to Civil Maths Concepts. It's Ramchandra again, and it is the 22nd lecture on structural analysis. Till 21st lecture, we have seen many concepts in the structural analysis. In this lecture, we will be looking into the beam deflection in overhang beams. And in the last lecture, we have drawn the shear force diagram and bending moment diagram for the overhang beam. And in this lecture, we will be completing the numerical whatever we have taken in the last lecture. And this is about calculating the beam deflections. If you see carefully and if you can understand and follow the total video one by one, step by step, then you will understand how to do for a overhang the analysis of the beam deflection. And in between, I will be giving the tips for the MCQs also useful for engineering services examination ESE. I have added ESE also in this because the same type of question is asked in engineering services examination UPSC and in GATE also, and in SSC JE. You can look at the theory part of the lecture, so that I will develop certain MCQs on this, and you can understand from the illustrations that MCQs, how the MCQs can be prepared and how the MCQs can be answered. And for SSC JE, GATE and ESE, this lecture will be very useful. This is overhang beams, how the deflection takes place and how will be the deflection curve. This is what we will be discussing today. And I am from Civil Maths Concepts. I am Ramchandra here. Welcome everybody. And in this, the same beam details are continued in the last lecture, from the last lecture. Please view the other lectures also from my channel. I will give the playlist link in the description for this video and also for the other videos. Please see them, review them, comment on them, and if any help is there, you please comment, and also please subscribe to my channel and spread this channel to other aspirants of SSC JE, GATE and ESE, so that they will also get benefited from the concepts which I am explaining here. Now, we will come into the problem solution. We had already done SFD, shear force diagram, and BMD analysis. We have already completed. Now, from this, we have to go for deflection analysis. Deflection of overhang beam. And beam is like this. This is RA, this is RB, this is 2 meters, this is 1 meter, this is C. A, B, C. Now, at a particular point, the deflection will be the maximum, and at a particular point, the deflection will be 0. And at free end, there will be a deflection. And here, you have to see that there are certain conditions, support conditions, which are required to be understood, which I have been explaining for the last 2 lectures. One is pin joint or pin support means theta is not equal to 0, slope is not equal to 0, but delta is equal to 0. Roller support means theta is not equal to 0, but delta is equal to 0. Fixed support means theta is equal to 0 and delta is equal to 0. And another thing what I have explained is that d by dx of mx is equal to shear force x, and integral of shear force x dx is equal to mx plus c1 These are the things which you have to know. And whenever, wherever shear force is equal to 0, that implies bending moment is equal to maximum. That also we know. And in this beam, shear force is 0 at 0.75, and at 0.75 we got the bending moment as 0.281, and we have got the values, and we understood in the shear force diagram and bending moment diagram. Now we will start developing the deflection curve. For developing the deflection curve, we require at important points what is the value of deflection and how deflection curve behaves, and at critical points what is the value of deflection, so that we can have a what you call a smooth curve for the deflection of the beam, a smooth curve. Now, at supports deflection is 0. First is at A is equal to at point A. It implies x is equal to 0 and delta is equal to 0. At point B, x is equal to 2 meters and delta is equal to 0. At supports, pin support and roller support. It's a pin support, it's a roller support. Don't worry for a small error of decimals, because we take 2 digits or 3 digits in our hand calculations. We are not doing the machine calculations. Hence, there can be error of approximation, some few digits, 0.001, instead of it can be 0.001 or 0.002. Don't worry for that. These are the boundary conditions we have. These we can rather call them as boundary conditions. And the beam is not closing or not ending at the support. It's extending. It's a overhang. It's extending. Hence, the third boundary condition, it's very important. Here, deflection is not 0. Deflection is 0 at the support B, but B is extended to C. But the rotation of AB is equal to rotation of BC. Portion is like this. Rotation of AB is equal to rotation of BC. When two numbers are connected by a roller support, here this is A, this is B, this is C. For ABC, B is the common. B is the common point. At the common point, the theta of BA is equal to theta of BC. Very, very important property you should know. The objective type question in the MCQ, it can be asked. In a overhang beam, which of the following are equal? At the common joint, where extension is made. In the otherwise they can say in the given diagram, which are the at point B, which are the following are common or equal at the point B. 1. The forces are equal. B. The moments are equal. C. The slopes are equal. D. The deflections are equal. Even though deflection is 0 on either side, slopes are equal there. Deflections are not equal. Deflections are equal. The deflections equal you can take out from the question can be framed like this. Question can be, which property of the beam at point B is valid? Answer A. The deflections of AB and BC at B, that is delta, is not equal to 0. B, they can ask like this. The slopes of AB and BC at B, that is theta, are not equal to 0. Theta are equal to 0. Third, they can ask another, they can give another option. The slopes at B on either side are equal. D, none of the above. In this, option C is correct because theta BA, in this direction theta, in this direction theta, both are equal. On either side or on either side are equal. The slopes at B on either side are equal. This is these three. One is at pin joint at x is equal to 0, pin support x is equal to 0, delta is equal to 0, and at another roller support at P, x is equal to 2, delta is equal to 0, that is roller support, and the rotations at the connecting point, that is P, of the beam sections AB and BC at the joint, a common point. At the common point on either side the slopes are equal. These are the three boundary conditions which we will be using to solve the beam theory equation. What is the beam theory equation? As per beam theory, EI into d square delta x by dx square is equal to mx. That much we know. D square delta x by dx square is equal to mx. On this also there can be a MCQ. They can ask the second derivative into EI is equal to mx, the first derivative into EI is equal to mx. They can ask the question, which of the following is true? One is the first derivative of EI, first derivative of deflection is bending moment. The second derivative of deflection is bending moment. The first derivative of the second derivative of deflection is a slope, and the second derivative of deflection is equal to 0. The answer is the second derivative of deflection is equal to bending moment. This is as per beam theory. EI into second derivative. EI you have to use. That is, EI is constant for the given beam. EI into second derivative of deflection is equal to bending moment at that particular point. Now, what is the bending moment in the portion 0 is less than x less than or equal to 2? Let us consider this portion first. In this portion, what is mx? mx is equal to, already we have done it, please refer to my previous lecture, 0.75x minus 0.5x square implies EI into d square delta x by dx square is equal to 0.75x minus 0.5x square. This is the equation from the beam theory. Now, integrating once, what happens? We will get, by integrating the beam theory equation for second derivative of reflection, when we integrate, it gives slope. Slope is equal to EI into d delta x by dx, that is equal to integration of 0.75x minus 0.5x square dx. This integration will be 0.75 x square by 2 minus 0.5 x cube by 3 plus integration constant C1. This is for slope. This equation is for slope. Now, we integrate further for deflection, integrating again, integrating second time, we get EI into delta x is equal to 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 plus C1x plus C2. This is what is the equation. This is for the slope and this is for the regarding for the deflection. Now, what are the boundary conditions? Applying boundary conditions. We got the equation. Now, apply boundary conditions. What is the first boundary condition? At x is equal to 0, delta is equal to 0. That implies EI into 0 is equal to 0.75 into 0 cube by 6 minus 0.5 into 0 to the power of 4 by 12 plus C1 into 0 plus C2. That implies 0 is equal to C2. That implies C2 is equal to 0. Now, the new equation will become now EI delta x is equal to 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 plus C1x plus 0. C2 is 0, that we need not write. Now, another boundary condition is at x is equal to 2, delta is equal to 0. That is another boundary condition. To get the constant of integration. Now what it happens? EI into delta x is 0. EI into 0 is equal to 0.75 into 2 cube by 6 minus 0.5 into 2 to the power of 4 by 12 plus C1 into 2. When you solve this, you will get these arithmetic things. You please do. When you solve it, you will get C1 is equal to minus 0.167. C2 is 0. Then, in the portion, 0 is less than or equal to x less than or equal to 2. EI delta x is equal to, for deflection, this is equal to 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 minus 0.167 x. This is the equation. For any value of x between 0 and 2. And let us see how to find out the point where delta x is maximum. That means for maximum delta x, d by dx of delta x should be equal to 0. That means slope should be equal to 0. This is also another MCQ question. For maximum value of, for finding the maximum value of bending moment, at the point of maximum value of bending moment, the slope is 0. The slope is 0. This is very important. What will be the slope here? D by dx of delta x. That means d by dx for slope. This 1 by ei, when it comes down to here, 1 by ei into d by dx of 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 minus 0.167 x. This should be equal to 0. Slope is this equation. Theta is equal to. This should be equal to 0. Then, this implies d by dx of 0.75 x cube by 6 means what it is? .75 x square by 2 minus 0.5 x cube by 3 minus 0.167. If you see previous equation, 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 c1x. Then only one integration when we have done. What was the equation? 0.75 x square by 2 minus 0.5 x cube by 3 plus c1x. Because we have to find the c1 value, we have got into all these details and we got the c1 value and we have substituted here. This is equal to 0. That means that gives a x value of 0.85 meters. That you please solve the polynomial equations, which is a part of your mathematics. I will not be dealing with that here. It's a very simple equation and you can easily solve it using trial and error method. For some positive value of 0.85 approximately, this equation is valid. X is equal to 0.85 meters. That means, till now what we have got? In the region 0 less than or equal to x less than or equal to 2, delta A is equal to 0, delta B is equal to 0, delta at 0.85 meters is equal to maximum. What is the delta 0.85 at x is equal to 0.85 because it is maximum? What is its value? Delta. You put x as 0.85 in the above equation. 1 by EI into 0.75 x cube by 6, 0.75 into 0.85 cube by 6 minus 0.5 into minus 0.5 into 0.85 to the power of 4 by 12 minus 0.167 into x, that is 0.85. When you solve it, you will get a value as minus 0.0867 by EI. This is the value of maximum deflection. And this value is minus 0.0867 by EI. EI is a constant, don't worry about it. This is the value of the maximum deflection. We have got the deflection at 3 points. We have got the maximum deflection also and point of maximum deflection. And we can draw the deflection curve for the first portion is like this: 0 less than or equal to x less than or equal to 2. That implies the curve is like this. The maximum deflection is here, and here it is 0 deflection. At A 0, at B 0, and here it is the maximum deflection, negative value, and by connecting these we will get let's make it as a curve, not as a straight line, so that this is the point of maximum deflection. Delta max is equal to minus 1 by EI into 0.0867, and it is at a distance of x is equal to 0.85 meters. This is the first part deflection curve. Now, let us imagine what happens. It is extended for 1 more meter here, and at this slope is same. With the same slope, the deflection will be like this here. This is our imagination. Whether our imagination is correct or not, let us see. We have to find out the critical values. At C, we have to find the deflection at C. Now, to find the deflection at C, we have to find out the deflection equation between 2 less than or equal to x for less than or equal to 3. For this portion, we have to find the deflection equation. The deflection equation between 2 and 3, it will be written as EI d square delta x by dx square is equal to 0.75, that is mx. mx is 0.75x minus 0.5x square plus 2.25 is the reaction there. That reaction is in this direction, hence it is made as a plus into x minus 2. It's x beyond 2 meters, which gives this derivation we have done in the previous class. See the previous video for the perfect to understand it clearly. That is equal to 0.75x minus 0.5x square plus 2.25x minus 4.50. 2.25x plus 0.75x is nothing but 3x. That means minus 0.5x square. By simplifying, we'll get plus 3x minus 4.5. This is the equation which is required to be integrated to find the slopes and deflection. First integration gives equation EI d delta x by dx is equal to 0.5 x cube by 3, this is minus sign, plus 3x square by 2 minus 4.5x plus C3, some integration constant. And this is equal to, for slope, this is rather, for slope theta. Second integration yields for deflection delta x, this is theta x, EI into delta x is equal to minus 0.5 into x to the power of 4 by 12 plus 3 into x cube by 6 minus 4.5 into x square by 2 plus C3x plus C4. These are the two equations where by using the boundary conditions we have to find the integration constants C3 and C4. Here for the portion 2 less than or equal to x less than or equal to 3, applying boundary conditions. What are the boundary conditions? First boundary condition is delta at B is equal to 0 because it's a roller support. Deflection is 0. And second boundary condition, not delta, theta BA, that is slope, is same on either side. Theta BA is equal to theta BC. These are the two boundary conditions we have to apply. This is at point B. At point B means at x is equal to 2. At a distance of 2 meters, these two conditions, when you apply these boundary conditions, we will get C3 and C4 value. Now, first boundary condition, deflection is 0. By applying this, as usual, as in the previous example, previous working, 0 is equal to, first one, we'll change the pen color, 0 is equal to minus 0.5 into x to the power of 4 by 12, x is 2 here, we can directly write x value, 2 square, 2 to the power of 4 by 12 plus 3 into x cube, that is 2 cube by 6 minus 4.5 into 2 square by 2 plus C3 into 2 plus C4, that is equal to 0. This particular equation yields, when you solve this, do it on your own, 2C3 plus C4 is equal to 5.67. You get this. First equation from the first boundary condition. Now, by applying the second boundary condition, what happens? Second boundary condition, theta BA is equal to theta BC. What is theta BA? Theta BA is equal to 0.75. In the first equation, if you see theta is first integration value, that is 0.75 into x cube by 6 minus 0.5 x to the power of 4 by 12 minus 0.1676 x. That is for theta. We'll write here for the portion BA, for the first portion, first equation. The first equation 0 is less than or equal to x is less than or equal to 2, theta BA. That equation to be used. That should be made equal to theta BC. 0.75 x square by 2 minus 0.5 x cube by 3 minus 0.167 is equal to 3x square is equal to, we can write clearly here, theta BC. That is equal to, this theta BC is for the portion x2 is less than or equal to x less than or equal to 3. That will be 3 into x square let us write like this, minus 0.5 into x cube by 3 plus 3 into x square by 2 minus 4.5 into x plus C3. By solving this equation, we will get a value of C3. Please do the solution on your own. C3 is equal to, putting x is equal to 2 in the above and solving, we will get C3 is equal to 4.33. We have got the value of C3. Now it is time for us to find out C4. We have already got C4 as 2C3 plus C4 is equal to 5.67. That implies 2 into 4.33 plus C4 is equal to 5.67. That implies C4 is equal to minus 3. We have got the value of C3 and C4. The final deflection equation for the portion 2 less than or equal to x less than or equal to 3. The final deflection equation will be this theta BA, the whole should be divided by EI. That you should know. Because EI I have not taken, because EI will get cancelled on either side for slope. Because EI is constant for the given cross section of the beam. For 2 is less than or equal to x less than or equal to 3, the deflection will be, what will be the delta x? Delta x is equal to minus 0.5 x to the power of 4 by 12 plus x cube by 2 minus 4.5 into x square by 2 plus 4.33x minus 3. EI into delta x. For the portion 0 less than or equal to x less than or equal to 3, EI into delta x is equal to, we have already got in the first portion. What is that value? 0.75 x cube by 6 minus 0.5 x to the power of 4 by 12 minus 0.167. These two equations are the deflection equations. Now, to find the deflection at C, this first equation will be used. This equation will be used. Deflection at C is equal to 1 by EI into minus 0.5 into. At deflection at C means x is equal to 3. We have to put x is equal to 3 because we have to find out at the free end. Minus 0.5 into 3 to the power of 4 by 12 plus 3 to the power of 3 by 2 minus 4.5 into 3 square by 2 plus 4.33 into 3 minus 3. This implies delta C is equal to 1 by EI into minus 0.125. This is the deflection at the free end. Now we will draw the deflection curve. Deflection curve will be like this. This will be the deflection curve. Sorry. At A, deflection is 0. At B, deflection is 0. At C, the deflection is minus 0.125 by EI, and yet here the deflection at a point 0.85 meters. This deflection will be maximum between A and B. The maximum value of deflection between A and B. That deflection is the maximum value of deflection at A and B minus 0.0867 by EI, and this distance is 2 meters and this distance is 1 meter. This is what we have got. Here we have found out the maximum deflection between A and B and also the maximum deflection between B and C. The maximum deflection is at the free end. Free end deflection is equal to maximum for the whole beam that is equal to minus 0.125 into 1 by EI, whereas in between the beam section for 0 less than or equal to or less than or equal to 2, maximum deflection is equal to minus 0.0867 by EI. And whatever maximum deflection previously we have discussed, that maximum deflection we have got for the portion between A and B. We have at that time we have not considered B and C. We have considered only for A and B, we have got the point of maximum deflection between A and B. Now, when we have considered the portion B and C, we have got another maximum deflection that is higher than the previous one, that is minus 0.125. For the whole beam ABC, in this section, we have got the delta max for whole beam ABC is equal to minus 0.125 by I. Delta max between 0 less than or equal to 2. That portion that is equal to minus 0.0867 by EI. In MCQs, to confuse, they may ask you to find the maximum deflection at a particular portion. Because deflection is becoming 0 between 2 points. Please try to understand the concept. Deflection is becoming 0 at 2 points. There can be a point where maximum deflection is there. That point is D. That is at a distance of 0.85. And having a magnitude. It may not be the whole beam deflection, maximum deflection. The maximum deflection in the portion AB is minus 0.0867 by EI. The maximum deflection, when you consider the other part also, it is becoming like this. And people usually, they check the maximum deflection at free and it is so and so. And they take some formula and they apply and they say that the maximum deflection. You have to see the question. The question can be like this. Question: what will be the maximum deflection between, because deflection is varying, the supports A and B for the given loading. We'll read only the portion maximum deflection. You should read the total full question. The maximum deflection between the supports A and B. They are not asking the deflection at the free end. There can be a question being asked, what is the deflection at the free end? That is the question asked in ESE, Engineering Services Examination 2017. Deflection at free end for an overhang. For an overhang. The same question need not be repeated. They may ask the deflection, maximum deflection, or point of maximum deflection between the supports. You please think out of the box and try to see that you will get the correct understanding of the question. Understanding the question is more important rather than answering. Answering is the most important. Answering should be the second part. First, understanding the question is to be the most important. You try to understand the question correctly. Then apply your formula and apply your concepts and get the answer. Here, the options can be, the first option itself will be misleading. Minus 0.0125 by EI. B, minus 0.0125 by EI. C, minus 0.0867 by EI. D, minus 0.867 by EI. You just see. Until and unless you read both the sentences, this sentence and also in which portion they wanted the maximum deflection, you cannot answer. The answer should be this one. not the first one. Please look at the answer, look at the question, understand the question thoroughly, then you please answer the question. And it's Ramchandra from Civil, MECH, Maths, Concepts. If this video has given you any value addition to your knowledge, please share, review, and comment. For comments, I will be giving replies, and you can subscribe to my channel. Please subscribe to my channel. Thank you for listening to me. Thank you for viewing my lectures. In the next, I am planning to take care of one of the most important another topic in civil engineering and mechanical engineering, that is fluid mechanics. One important topic of calculation of hydrostatic pressures. I left fluid mechanics almost 1.5 months back. I have already given many lectures on it. I want to make this structural analysis and also fluid mechanics go together. From now on, we will restart the fluid mechanics, and in the fluid mechanics, I plan to make you understand the concepts of calculating the hydrostatic pressure on curved or vertical plane surfaces. Best of luck to you. Thank you for listening to me. Next class will be fluid mechanics, hydrostatic pressure on vertical plane surfaces, either partially or fully submerged. Fully submerged or immersed. And there can be curved surfaces also. We will go for it in the next lecture, fluid mechanics. And alternately, to the maximum extent possible, alternately I will take fluid mechanics one class, and next I will take structural analysis in another, so that we will try to move ahead in both and we try to complete the syllabus, other topics also. We will merge the other topics also. Thank you. Best of luck to everybody. And this my lecture will be useful not only for SSC JE, it will be useful for GATE and also ESE, UPSC Engineering Services Examination, and also Public Service Commission's Assistant Engineer Examinations also. Thank you. Best of luck.